Scenario number 1 says that if 7 of the students who entered a recent poetry slam were awarded a personal coaching session with one of the nation's top 10 poets, then in how many ways could the prizes have been awarded? In this particular case, we have 10 poets. Assigning these 10 people to the 7 students, in this case the order will matter. One poet, let's say his name's Henry, is going to be different than another poet, let's say Sarah. When I go to assign the very first student, it will absolutely matter whether I assign Henry or I assign Sarah to that first poet. In this particular case, order matters. I'm looking for an arrangement in which I'm going to give 10 poets to 7. If order matters, I need to use permutations. So I'm trying to take 10 things, 10 poets, permutate them, determine an order, where order matters, for 7 things, or an arrangement of 7. So this is the number of ways that I can arrange all 10 awards, and then it takes out the number of ways that I can arrange them for the 3 extra poets that aren't going to get assigned to anyone. 10 permute 7 is going to give you a total of 604,800 different ways. And that comes from taking 10 factorial in the numerator and dividing by 10 minus 7 that quantity factorial, or 10 factorial divided by 3 factorial. And you can do this by hand or with your calculator. So we just did an example of permutations. Let's take a look at combinations. Okay, scenario number 2. If 7 of the students who entered a recent poetry slam were this time awarded one of just 10 general admissions tickets to the 2013 National Poetry Slam, then in how many in how many ways can the tickets be awarded? Well, in this particular case, I just have 10 general tickets. When I go to give a ticket to the first person, it will not be any different than the ticket that I give to the 3rd person or the 7th person. In this case, the order does not matter. It does not matter whether I give ticket 1 to the first person and ticket 2 to the second person, or whether I give ticket 2 to the first person and ticket 1 to the second person. It doesn't matter because all the tickets are exactly the same. Okay? When order does not matter, that's where we use combinations. And we saw combinations when we did our binomial expansion. So in this particular case, I want 10 things, 10 tickets, and I want to choose 7 of them. And the order of those 7 is completely irrelevant to me. Right? I'm just going to give or group 7 of those tickets away. Okay? This particular answer is going to give you 120. Notice we have a much smaller number of ways that we can give out awards because of the fact that the order does not matter. And when we take a look at doing this by hand, we know that we're going to end up doing the 10 factorial divided by the 10 minus 7 factorial, but then also still times that 7 factorial. I'm dividing out more ways that just don't matter to me because that order doesn't matter. So in general, let's review just our general formulas here. Let's do one for combinations. Okay, for combinations, N choose R, the number of things combined, the combinations of N things taken R at a time. This is equal to N factorial divided by N minus R factorial times R factorial. If I take a look at permutations, in general, making sure that I have my formulas clear, permutations, again, order does matter. In permutations, I have NPR, okay, the number of permutations with n things taken r at a time. This time, it is n factorial just divided by n minus r factorial. So again, let's review. If I have permutations, order matters, and this is my general formula. If order does not matter, those are going to be combinations, and I'm going to use this formula. Let's take a look at trying to distinguish between the two in our next scenario. Scenario 3, we want to choose between permutations or combinations and then actually find the number of ways. Okay, first one, let's talk about the number of ways to introduce 5 starting players on the basketball team. Okay, I want to introduce 5 basketball players. My question to myself is, does order matter? So every time I'm thinking in my head, does order matter? Does it really matter how I introduce these basketball players? Okay, in this particular case, it does. Right? They will be 5 different players, and the order in which I announce them is going to vary based on which player comes first, then second, then third, then fourth, and so on. So in this particular question or scenario for the first one, the answer is yes, order matters. If order matters, then I'm going to do permutations. Okay, permutations. I have 5 basketball players, and I want the number of ways that I can permutate 5 things taken 5 at a time. I'm going to pick all of them, but it actually matters which order they're occurring. 5p5, right? This is going to be equivalent to just 5 factorial, because I'd be dividing off by 0 factorial or 1. Okay? And this gives me 120 different ways. Okay, next example. Okay? The number of ways to check out 3 library books from a list of 8. Okay? The question is, does it really matter, right, the order in which I check out those 3 books? Okay? So the number of ways to check out 3 library books from a list of 8. Well, you pick out the 3 books, right? But whether they scan the first or the second or the third, or they go in reverse order, really is not important to me. I'm just checking out the 3 books, picking those 3 books out of a list of 8. So the order in this case does not matter. Okay? If the order does not matter, this is a combination of, I'm going to have 8 things, and I want to take them in a group of 3. Okay? I have 8 things, and I'm going to choose 3 of them. Okay? This is going to give me 8 factorial divided by 8 minus 3, or 5 factorial, and then also times the 3 factorial. This gives me a total of 56 different ways for me to choose 3 books out of a group of 8. Let's take a look at our next one. The number of ways to select 4 students from a pool of 7 candidates. In this particular case, it doesn't really matter who I'm picking, right? The number of ways to elect 4 students from a pool of 7, right? I'm just choosing 4 of them. It doesn't really matter who gets picked first. I'm just picking 4. In this particular case, again, the answer is no. Right? It's no because I'm just picking 4 students. They all have the exact same role. They all have the same role. I just am grabbing them. So this is going to be 7, choose 4. combinations, and that's going to give me a total of 35. In my fourth scenario here, though, I want the number of ways to elect 4 people, so very similar to the previous one, out of a group of 12, but this time they're going to serve. One is going to be a president, the other one's going to be vice president, then secretary, and then treasurer. So once I pick someone for the president, I can no longer pick that person for vice president. And so since they have different roles, picking the order actually does matter. So the answer is yes, my order does matter, and if the order matters, I use permutations. So this is the number of permutations of 12 things taken 4 at a time. I have 12 different students, so I have 12 different options for the first president, then I have 11 options for the vice president, secretary has 10, and then treasurer has 9. This is going to be equivalent to 11,880 different ways. Final part in scenario 3. This one is a little bit more tricky. I need to combine things. This time I want the number of ways to assign 10 A's, 8 B's, and 7 C's to the 25 students in our Honors Algebra 2 class. Well, let's actually use our counting principle here, right? And let's say this is the group of students that I'm going to assign to A's. These are the students that are going to get B's, and these are the students that are going to get C's. Let's start with the first one. I need to give 10 A's out to students. To give 10 A's out to students, I have 25 students, and I'm just going to choose or pick 10 of them to get A's. Well, now that I picked 10 and those 10 students get A's, now I'm down to only 15 students to choose from. So I have 15 students to choose from now, and I'm going to choose 8 of those kids to get B's. Then lastly, I only have, if I choose 8 out of the 15 that were remaining, now I'm down to only 7. And this time I'm choosing out of the 7, I'm going to assign all 7 to get C's. Well, if this is the number of ways to get A's, and this is the number of ways to get B's, and this is the number of ways to get C's, then I want to multiply these based on our counting principle. If I multiply all of these out, I end up getting 2.1034, I'll round, 5 times 10 to the 10th. Okay? That is a significant number of ways in which I can just assign grades randomly to the 25 students that are in our honors class. Okay, last example. In scenario 4, we want to take a look at how many ways we can arrange the letters in the word isosceles. Well, this poses another problem to us. If we take a look at the word isosceles, in isosceles, we have some repetition. I have a letter I have a letter S, I have a letter O, then S is repeated, so I have 2 S's. Then I have a C, then an E, okay, then an L. Okay, the E is repeated a second time, and then my S is repeated a third time. So I, O, C, and L, those all only occur once. Well, typically, if I just want to assign letters, if I just want to assign labels, things, these things to my spaces, isosceles has how many different places to fill? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 different spaces in my word isosceles. So there are 9 spaces total to fill. Typically then, I would just say the number of different ways that I can fill those. I have 9 spaces. I'm just going to do 9 things, and I'm just going to pick 9 of them at a time. So it would be 9 factorial. But the problem is I have these repeat letters. And it doesn't really matter which of these S's comes first, it's still an S. So I want to divide out. I want to remove or divide by the repeats. Anything that repeats itself, I'm going to eliminate. So I had an S. That S is 1, 2, 3. 3 S's. I'm going to divide by 3 factorial because there are 3 different ways, or excuse me, 3 factorial ways in which I can arrange those same S's. Then there are 2 factorial ways that I can arrange the E's. It could be the first E with the second E, or then the second E first and then the first E. If I simplify this, it gives me a total of 30,240. I'm going to leave you now with a similar question. Right? My question to you is, I'd like you to try to bring this answer to class. I'm asking the same question. How many ways can you arrange the letters of the word? And this time your word is going to be Tennessee. 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 Okay? Try to figure out how many different ways I can arrange the words or the letters, in the word Tennessee. Okay? Bring an answer to class for me tomorrow.